Hello everyone, this is Shivani Srivastava, and today we are going to study about resistance. Resistance, or else you can say combination of resistance. So first of all, to know about resistance, we need to know why we are using it and where we are using it. So resistance in electricity, as we are talking about electricity, so in electricity, resistance is the substance which opposes the current. Means we can say resistance opposes the flow of current. Okay. So now what is current? So current is what? Rate of flow of charges. Rate of flow of charges. Current is rate of flow of charges. So what is mean by this rate? I can understand you are aware about this rate. This rate is money. No. Rate means you can say divided by time or per unit time. So whenever we are multiplying anything with the time, then it means that is rate. Okay. So flow of charges means rate of what? Flow of charges. We can mention it like this. Now, current is what? Now, by the definition only, we can get current is equal to charge upon time. We can write it like this, right? Like current is equal to charge upon time, rate of flow of charges. So, current is denoted by what? Capital I. And charge is denoted by Q upon T as usual. Okay, time is denoted by T. So we can say I is equal to Q upon T, right? So what will be the unit of current? Unit of current is ampere. Unit of current is ampere. Okay, unit of charge is coulomb. This is revision only. And unit of time is second. We know it. Okay, so unit of current is ampere. And what instrument we are using to measure the current? What instrument we are using to measure the current? So we are using a meter. We are using a meter to measure the current. And to know the direction of current, we are using a different instrument that is known as galvanometer. Galvanometer. So galvanometer we are using to know the presence of current and the direction of current, in which direction the current is moving. Okay. And ammeter we are using to know about the amount of current. So I think you are aware about it. You got it very clearly. Now we are moving on our concept, like how the current is moving in a circuit. So the current is moving in a circuit with the help of battery only, right? So we need to know about the battery. So this is what? This is a symbol of battery. This is positive terminal. This is negative terminal. The big one is the positive terminal and the small one is the negative terminal. So we can forget it also, right? This is our mind only. It will get confused. So how we'll remember this bigger one is a positive terminal and a smaller one is a negative terminal? So we can learn it wise. See, this is a trick only. Just for fun, I'm telling it. So here, this negative terminal is having very small, a single line. Okay, a single line, it means small. And positive symbol is having two lines in it. Okay, one is vertical and one is horizontal. Okay, one is horizontal and one is vertical. So when we will add these two, this one is horizontal one and this vertical also if we'll add, so this line will be bigger, right? So it will be a bigger line. So in positive symbol, two lines are here. So we can say it's a bigger one, and in negative, one single line is here. So we can say it's a smaller one. So this is what? Positive terminal and negative terminal. Okay, so this is the symbol of battery. Now we need to connect one key over here. Then the current will start flowing through any circuit. And resistance could be any appliance in our home, like AC, TV, fridge, and like bulb. All the appliance which we are using at home, we can say those all are the resistances only, because current is moving from them. AC, TV, fridge, bulb, a toaster, mixer grinder, and anything, any electrical appliance, that is the resistance only. And resistance, you can say, are applying in all the appliance in a very short form that we will discuss again. This I'm just telling you in short way. So current is moving in the direction from positive terminal to negative terminal. I think you will not be confused on identifying the symbol. So the current will move from positive terminal to the negative terminal. Okay. And this resistance is opposing the direction, like opposing the flow of the current. Got it? So this is what? Battery. This is battery. So battery helps to flow the electron. Battery helps to flow the electron. Means the battery is this voltage. We are getting voltage because of the battery, and the battery helping the flow of the electron. Battery is giving the energy to flow the electron. We can say, like as we are having food, so that we are getting energy. Similarly, battery is giving energy to the electron so that it can move from one terminal to the another terminal. Got it or not? Like how it is giving energy? Means you can say that electrons are at this terminal. So like from this terminal, it is giving energy to the electrons to flow. Okay. This is one electron only. It is not producing the electron. Battery is not producing the electron. You should remember about it. Battery is not producing the electrons. Electrons are everywhere in every like wire and all. You must have learned about the cell. Okay. So these are the electrons present in the wire, you can say. And the electron which is here nearby the battery, you can say. So the battery is giving energy to this electron so that this electron will start move from here and will come here. Means battery is giving energy to this electron. That's why this electron starts moving and again it will come to here. So battery is not producing the electron. Battery is giving energy to the electron so that it can complete one cycle. And because of this completing one cycle only, the current is produced, you can say. Got it? So this much I want to tell you before starting the resistance. So as we know that current is moving, means sorry, electron is moving from one terminal to the another terminal. So if we'll consider it like this is a wire. This is a wire. We'll consider this is a wire. So electrons move from this one position to this one position. Like this only we have considered, okay? That electrons starts moving from this position, okay? From this position to this position. So we'll consider they have traveled this much distance. They have traveled this much distance because it is a very short distance. So we can consider it as dt. So to the very short distance, we can consider it as dt, and electrons are moving from here to here in this area. So what we can say? We can study about the charges, right? So dq. Why we have taken this d? D means what? Very small quantity. Whenever we are taking, then we are taking is as dq. So q is equal to ne, as we know. Like what is this? Charge. Q is what? Charge. N is what? Number of electrons. Okay. And E is charge of electron. Charge of electron. So here we are talking about very small area. So we will say dq is equal to N, number of electron, the same, into charge of electron. Right? Number of electron and charge of electron. Now, as we can say, number of electrons crossing through the area. Number of electrons crossing through the area. So, we can say number of electron, okay, and area. Area and distance. There will be the particular distance also, na? Distance, like how many distance it traveled, how much distance it traveled in a cross section area into charge of electron, okay, and dq. So how we'll find out the distance? How we'll find out the distance? So we know velocity is equal to distance upon time. Velocity is equal to distance upon time. Velocity is equal to distance upon time. So here, as electrons are moving in a circuit, so they are colliding and all. So here the velocity will take the VD, drift velocity, is equal to distance into a very short time we are taking here. That is why we took like dt, right? So we'll write it as dt. So this distance will be what? Vd into dt. Can we put it over here? Of course we'll put. Okay, so dq is equal to n into vd into dt into area of cross section into electron, charge of electron. Now we can do this dt below this q, right? So what it will be? dq upon dt. dq upon dt is equal to n into vd into area of cross section into electron. Now this dq upon dt is what? Before only we have discussed about it. What we have discussed? Current is equal to charge per unit time. Current is equal to charge per unit time. So we can put it like this, right? So in place of dq upon dt, we can put I. So I will be is equal to n into Vd into A into charge of electron. Now, if we'll rearrange it, so we can write it as I is equal to VDE NA. We can write it as, right? So here it's a short trick also. We can learn it as I is equal to Vina. Okay, this D you just ignore. So it will be like Vina. So it's a short trick over here. So you can learn the formula directly is equal to like I is equal to VD into E into N into area of cross section. So please don't go on it. I'm just rubbing it. It was a short trick only. So I think you must have got this derivation. Now here, what we'll discuss? Here, as you got it about like V is equal to VD into E into area of cross section. Now you should know, you should aware about it. Like charge of electron is constant always. Charge of electron is always constant, right? Charge of electron is always constant. Now, number of electrons in a circuit. If we'll take about a small place or full circuit, whatever it is, the number of electrons always, that also will be the constant, right? Area of cross section is what? In this, I is equal to VD into ENA. E is the charge of electron. Okay. N is the number of electron. A is area of cross section. So here that all will be what? Constant only. constant only, right? So we can just take it as a constant. Now we can do it. I is directly proportional to velocity. Okay. And if we will remove this proportionality sign, so we can say we can put all these constant. From here only, the Ohm's law generated. The same law is given by our great scientist Ohm. Okay, so I is directly proportional to voltage, means current depends on the voltage. How much we are taking the voltage, that much only the current will be here. So current is generated because of the movement of the charges. And why the charges are moving? Because battery is giving energy to the charges. Okay, so that much only we need to discuss till now. Now, as I told you, today we'll discuss about resistance, but till then, I just explain you all the process like voltage, current and all. So this much, I think you must got it. Now, Ohm's law. What is Ohm's law? Now, Ohm's law. So here, the main thing which we should know, Ohm's law is not applicable at all the places. It is not working at all the places. There is some restrictions. Okay. Like there should be the ohmic conductor, like conductor should not be changed. Temperature also should be constant. That is. So first of all, we'll start the definition from here only. At constant temperature. Constant temperature. At constant temperature, current is always directly proportional to voltage. Or you can say voltage is always directly proportional to current. Whatever you want, you can say. So at constant temperature, current is always directly proportional to the voltage. Like I just thought this statement is more correct. That's why I am writing this. But in some books, you will get it like voltage is always directly proportional to the current. Why? Because current depends on the voltage. Okay. Now that is a different thing. So we can write it as V is directly proportional to current. You can take it as up to you. Now, when we remove this proportionality sign, then here will be one constant. Okay, that constant we can say is R. Okay, this formula will be V is equal to IR. Before we have known this formula, now this is according to our 10th grade. In 10th grade, we have studied about it. Okay, so you must have learned it in the 10th grade itself. Okay, so V is equal to IR, from where we can say R is what? Resistance. You remember or not? Resistance. Okay, and resistance depends on length of the conductor. Resistance is inversely proportional to the area of cross section. So resistance depends on the length of the current. The conductor resistance is inversely proportional to the area of cross section. We will take these two equations, and when we'll combine it, then resistance will be directly proportional to length upon area of cross section. And when we remove this proportionality sign, then here will be resistance is equal to rho L upon A. This you can go from, you can like revise from your 10th grade book. R is equal to rho L upon A. Okay, but here we'll discuss about like in a different way about this resistance and all. So from where we'll get the resistance? Now we are going for it. So length, you get like y depends on the length. So you just can assume it by the example of terminal. Like this is a terminal. This is a tunnel, you can say, sorry. a tunnel, and you are standing over here. So if you wants to go from this tunnel, so how much the length will be, that much you will feel trouble on the way. It means if length is more, then you will feel trouble of also more. Means that trouble is only resistance. So that's why it is directly proportional to the length. And if the area of cross section is more, then it will be easy for you. But if it is less, then it will not be easy for you. So it means it is inversely proportional to area of cross section. If area is more, then your difficulty is less. If area of cross section is less, then your difficulty will be more. That much only. I think you must have got it. Now we are moving on resistance, a proper definition about which I was telling I want to tell you. So resistance is the opposition towards any material. Okay. So we can say property of a material to obstruct the flow of current. Property of a material to the flow of current. Okay. Property of a material to obstruct the flow of current. So what we can say, we know like I is equal to V na, the same. I is equal to Vd into E into number of electrons into area of cross section. So Vd is what here? Drift velocity. But here we'll discuss about the velocity only. So as this is the drift velocity, so what is the formula of drift velocity? Drift velocity is means what? When the electrons are colliding with each other when they are moving on the same terminal. So it depends on the electron, the velocity, okay, upon mass of the electron, length in which it is moving, and tau. Tau is what? Relaxation time over here. Relaxation time. Like when the two electrons are colliding now, like if this is a wire and there is one electron, these both electrons are colliding to each other. So they are getting relaxed now, like this electron will go collide to this electron, again this will go and collide to another electron. So there will be one relaxation time now. So that is only known as the relaxation time. What is this? Relaxation time. You must have aware about it. Yes, I am jumping to the topics. Okay. So I will be is equal to EV upon ML tau into E into N into A. Now what we can do? I is equal to V tau upon ML, this E square into N into A. Now, what we can do? Just we need to do the cross multiply. First of all, we'll rearrange all the things. So how we'll rearrange? This V we will take our side. I is equal to NE square tau upon ML into A into V. Okay? This much in. Now, this V we can take this side to this LHS. Yes, of course we can take. So, or else I this side. So V upon I is equal to ML upon NE square into tau into A. Now, as we have discussed just now, V is equal to IR. Okay, so I will be is equal to, sorry, not I. So V upon I will be is equal to R. Right? If V is equal to IR, so V upon I will be is equal to R. Similarly, here also V upon I is this, so we can put it here R. So R will be is equal to ML upon NE square into tau into A. So this is the formula of resistance. Means on which factors the resistance depends? Mass, also length, okay, and number of electrons, tau, area of cross section. Okay, tau is what? Relaxation time. N is what? Number of electrons per unit charge, like number of electrons only in a circuit. And electron is what? Like E is what? Charge of the electron. Okay, got it. So this much is about resistance. Now, what is the symbol of resistance? Symbol of resistance. What is the symbol of resistance? Symbol of resistance will be this. Okay. So this is the symbol of resistance. Unit of resistance. Unit of resistance will be ohm. And we can represent it as ohm. Okay, we can represent it as ohm. Now, again, I'm writing the formula of R. So R, we got the formula. R is equal to M into L upon N E square into tau A. Now, you remember the formula which we have wrote according to the 10th class. R is equal to rho L upon A. So, if we'll compare these two equations, this first equation and this second equation, if you'll compare these two equations, so what you'll get? Rho is equal to M upon Ne square tau. So this is the rho. This is what? This is rho. Rho is what? Resistivity of a conductor. Rho is the resistivity. Rho is the resistivity of the conductor. Resistivity means property of the material. Rho is the resistivity of the conductor, which depends on the relaxation time. Which depends on the relaxation time. Okay. And what is the relaxation time? When the electrons are moving in a conductor. Okay. So they are getting collided to each other, we can say. So this electron will collide to this electron will collide to this again will collide to this. So there is the relaxation time. Like they'll take rest also now for a few time. Like you all also can't do continue work. So similarly, they will also take rest in between a time for a few time. Okay. So that is a relaxation time. So this relaxation time varies according to the variation of the temperature. This relaxation time will varies according to the variation of the temperature. Okay, this relaxation time will vary according to the variation of the temperature. So that is why we can say resistance, like the factors on which resistance depends. Okay, factors on which resistance depends. So length, area of cross section, and temperature, and quality of material. Obviously, it depends on the material also. Okay, length, area of cross section, temperature, and material of the body. I think now you must have aware about this resistance. Now, in the next lecture, we'll describe about the combination of the resistance also. Okay. Thanks for giving us time. Thank you so much.